Okay, so today I'm going to be going over nodal analysis. So this is our circuit. And there should be one more resistor right here. Okay, so we want to find VA, VB, and VC. So we have three nodes that we're going to be finding. So we're going to put VA right here, VB here, VC, and then this is going to be our ground, which we're going to label V out. Okay, so we're going to start with VA. So we have three branches to VA. We have 1, 2, and 3. So we're going to do the power supply last. So we're going to go from VA to VB. We're going to do VA minus VB all over 5 ohms. And then we're going to plus VA minus VC all over 4 ohms. And then we are going to do plus VA minus 5 volts is all equal to 0. And we do minus 5 volts because we're going into the positive side and out through the negative side of the power supply. Okay, let's go to VB. We have 3 branches of VB. We have 1, 2, and 3. So we'll do VB to VA first. So VB minus VA all over 5 ohms plus VB minus V out, which is our ground, all over 2 ohms plus VB minus VC all over 1 ohm, which is all equal to 0. And then we will do VC. So VC minus V out, which is ground, all over 2 ohms, plus VC minus VB all over 1 ohm, plus VC minus VA all over 4 ohms. So that's all equal to 0. Next, we need to get a common denominator for each individual equation. So for VA, we're going to multiply the entire equation by 20 so that we do not have any denominators. And then for VB, we're going to multiply the entire equation by 10. And VC, we're going to multiply the entire equation by 8. So now we will rewrite our equations. So VA, so it's 20 VA minus 20 VB all over 5. So we're going to go ahead and reduce that. So we get 4 VA minus 4 VB plus 20 VA minus 20 VC all over 4. And we'll reduce that. So plus 5 VA minus 5 VC plus 20 VA minus 20 times 5, which is 100 volts. And that all equals to 0. And then for VB, we multiply the entire equation by 10. So 10 VB minus 10 VA all over 5, which reduces to 2 VB minus 2 VA plus 5 VB minus 5 V out, which is our ground, plus 10 VB minus 10 VC, all equal to 0. And then for VC, we multiply the entire equation by 8. So 8 VC minus 8 V out over 2, which gives us 4 VC minus 4 V out plus 8 VC minus 8 VB plus 2 VC minus 2 VA, all equal to 0. And if we go back up to our circuit, V out is just ground, and ground is equal to 0. So we can get rid of all the V outs in our equations. So this goes to 0, and this goes to 0. Now we're going to rewrite our equations again with combining like terms. So VA, we're going to combine all the VAs. So that gives us 29 VA minus 4 VB minus 5 VC, and we're going to move the negative 100 volts to the other side. We're just going to add it, so we get a positive 100 volts. And then for VB, we're going to combine all the VBs, so we get negative 2 VA plus 17 VB minus 10 VC is all equal to 0. And then for VC, we're going to combine all the VCs. So we get negative 2 VA minus 8 VB plus 14 VC, all equal to 0. And the easiest way to find each variable is to do the matrix math. So we're going to make a 3x3 matrix with VA, VB, and VC, and all the VAs will be in one column, all the VBs will be in their own column, and all the VCs will be in their own column. So it will look like this. These are all the VAs, and then the VBs, and then the VCs. And then we're going to make another matrix with the right side of the equation. So we just have 100, 0, and 0. And then we are going to plug this all into the calculator. To do this, you go to matrix and you make a 3x3 matrix, plugging in all your numbers. And once that's done, you make a 3x1 matrix. And then you are going to take the inverse of your 3x3 matrix and multiply that by your 3x1 matrix. And that will give you your answers. So VA is equal to 3.82 volts. VB is equal to 1.16 volts. VC is equal to 1.21 volts. And these are our final answers.